For this video, I'm going to show you how to analyze piecewise functions, including how to find the domain and the range, and then how to evaluate the function for a given number. So as a reminder, a piecewise function is actually a combination of different functions, but each with its own specified domain. So for example, there's the graph of negative x squared plus 2 that we all know and love. This is the parabola shape that's facing down and it's been shifted up. And then we have a separate graph of y equals 2x minus 1. So this is more like our slope-intercept straight line function. However, off to the side, we have some domains specified. So what we're going to do is we're going to use these two shapes, but we're going to cut them off where x equals 1 on the x-axis. And then we're going to have this shape on the left side of x equals 1, and then this shape on the right side of x equals 1. So you can see that those two pieces are being combined here, with the cutting point being that x equals 1 value specified by the domains here. This video is going to focus more on the algebraic side of things. So if you're given an x value to plug in that's smaller than 1, like 0 or any negative number, for example, then I would know to plug it into this top equation because of what this domain is specifying. And then if I was to plug in a number bigger than or equal to 1, then I would know to plug it into this equation to evaluate and see what number I get. For a couple reminders, since we will be doing things like the domain and range, don't forget that in interval notation, we use those square bracket symbols to include the endpoints of an interval, and we use the parentheses to exclude the endpoint of an interval. And you can have a mixture of them, so it might be the square bracket on the left side and the parentheses on the right side, because each endpoint has its own consideration for whether it's included or not. If we just need to list out specific numbers, then we use the curly brackets and we separate them with commas. And don't forget that the domain is the x values. So we're going to be looking from left to right. What does the graph include? And for the range, we're going to be looking up and down in the graph. So what are the highest and lowest points it hits? The process for evaluating a piecewise function is basically dependent on being able to identify which function you need to plug into first. So to identify the function you want to substitute into, focus on the domain part, which is just to the right of the formulas, and then you should be able to identify, okay, well this number falls between these numbers, so now I know to use like the second or the third function, whichever one you have, and then you can form the substitution for your second step and do any simplifying that you're able to. So here's an example where there's actually not much to compute, because you'll notice that all three of the pieces in this piecewise function, none of them have any x values. So there's nothing that can be substituted in to evaluate. And this is actually common with a lot of pricing schemes for things like the cost of a movie ticket. So movie ticket prices vary with your age. And the idea on this is if I know the age of the person I'm buying a ticket for, then we can identify which of these three brackets the person falls into, and then determine the price based on that. So we don't have to worry about any x's to substitute. It's just going to be one of these three numbers. So the first part of this question is asking us to identify the domain. And the domain I can identify by looking at the specified domains for each individual function here to the right of the y values. So the smallest number that we have on this one goes from 2 to 13, and it doesn't include the 13, but it does include the 2. And then the next function picks up at the value of 13 and goes all the way up to 60, but does not include it because of the symbol indicated here. And then the last function is going to be used for any numbers bigger than or equal to 60. So this one continues on forever for any number bigger than that. So if I'm trying to identify my smallest and biggest numbers, I can see that the smallest number we ever showed was the 2. And since we did include the endpoint, it says x is less than, or rather x is greater than or equal to 2. That means I can use 2 as one of my endpoints. So this is going to be a bracket on this number. And then for the largest number my graph ever hits, we went all the way up to 13, and then we started again from 13 to 60. And then this graph said any number bigger than 60. So this can technically go on to infinity, even though it might be kind of weird to consider somebody hitting ages over even 100, honestly. And then we always use the parentheses with the infinity symbols. So the x values covered by this function are anything from 2 or higher. Now the range of this function is going to be a little strange because usually we have lots of numbers, in fact like an infinite number of numbers. Usually we're saying everything bigger than 2 or everything between 5 and 13. But in this case I actually only have 3 very specific numbers I can get from my range. I can get 10.69, 13.69, and 12.69 depending on the age of the person buying the ticket. So since we don't need to worry about the decimals or the fractions between these or any of the numbers smaller or bigger than these numbers, we actually want to use the curly brackets in this case, and I just need to list the individual numbers that we can obtain. So I'm going to have the 10.69, and then I need to separate this with a comma from the next number, 13.69, and then the last number I can possibly get is 12.69. So this is one of those strange cases where we do not need to use interval notation because I'm trying to specify these 3 numbers and these 3 numbers only, not any of the other numbers around them or in between them. And for the last part of this question, they're asking a hypothetical: if you are 16 years old, how much will your ticket cost? So you would refer to the domains to find which one the 16 lands under, and in this case that would be the middle set of values between 13 and 60. So I can now see that the 16-year-old would have to pay $13.69 for that ticket. So this is a strange function in the grand scheme of things with what we will usually do with piecewise functions, but sometimes these cases where you don't actually have any x's to plug into, you just have specific numbers, sometimes those are the ones that confuse students the most. So I wanted to make sure to cover an example like this. And it might seem weird that your domain does not include the numbers from 0 to 2, but the idea behind most of the pricing schemes on a theater is that they don't charge a ticket for somebody who's only 1 year old. They're expecting them to sit in the lap of their parent. So we're only having to buy a ticket for somebody 2 years of age or older who uses their own seat in the theater. So this example will have more in common with most of the types of problems you'll do with piecewise functions. Usually there is a function that has an x in it so that there's actually a number to substitute in and evaluate. So this time we're doing the cost of hiring a catering company for a dinner, and the cost of hiring that company will vary based on how many guests will be attending. So a lot of times the more people attending a function, the less they charge per person. So the first piece of this question is asking what is the domain of the function. So again, the domain is going to be coming from the numbers I have listed here on the side. The smallest possible situation for hiring a company is starting with 1 guest. So if they're not even making a single dinner, then what are we hiring them for? And then this function applies to all the numbers all the way up to 15, which is then taken over by the middle function. So if you actually have 15 guests, we would start using this middle equation. And it goes all the way up to 40, but not including the 40th guest, because as soon as you hit 40 guests, you actually jump down to the third function shown here. So for 40 or more, we can use the cheapest rate of $30 per dinner. So my largest number goes to infinity. Again, it seems kind of weird to say that we might have an infinite number of guests, but they just don't put like a maximum on it. So they'll usually say however many you have. Really, they're going to run out of space in the venue before they run out of the ability to make dinners. So I am including the endpoint of 1, so I need to use brackets on that number. That's the smallest one we ever hit. And then we always use parentheses for the infinity symbols. So since this graph did not cut off at a certain maximum limit, it's just going to continue on forever to infinity. Next, we have the range of the function. The range on this one, again, I don't have the graph to look at for reference, so we're going to need to try to compute this by saying what would be the smallest possible price we would pay and what would be the largest possible price that we would pay. Well, for the smallest price, I can actually use my domain and recognize that if I only buy dinner for 1 person, that should be the lowest case I possibly have to worry about. So by plugging in x equals 1 into this top function, I get that the smallest price is going to be $50. So if I buy a dinner for myself with this catering company, I'm going to be paying $50. Now the largest possible price is again going to come down to the fact that there is no limit on how many guests I could conceivably have. So I could potentially have them make an infinite number of dinners, in which case the 30 times infinity will still give me an infinite cost. So my range does not have a capping out point. It goes all the way up to infinity. And I am possibly going to be charged the $50 fee. So I have the bracket on the 50 in this case. And then the last part of the piecewise function is to predict the cost based on a certain number of guests. So if you were expecting 42 guests, you could start off by looking at the pricing scheme and say, okay, well, which price am I going to be paying per dinner? It's not the 50 or the 40, it's a number bigger than 40 guests. So I know I'm paying the $30 per dinner. So now I just know that I'm plugging in X is 42. So I'm going to compute what is 30 times 42. And the answer you'll get for that is going to be $1,260. So now you have an idea of how much this catered dinner would cost, assuming that your number of guests is accurate. And that's going to be it for this video on piecewise functions. In the next video, we'll focus a little bit more on the analyzing them graphically and identifying some other elements like the increasing and decreasing intervals and the maximums and minimums.